All right, ladies and gentlemen, coming down to the last 2 weeks here. We're going to finish up our function stuff this week, and then assignment 3, we'll just go over something a little bit different to kind of start to wrap things up. All right, but function transformations. Now, you have seen this stuff before. In fact, we've done problems like this right here. And I think you'll realize what I mean by transformations. It's just shifting the graph, changing the graph based on what we're adding to the original function. Okay, so first off, just to review, these are all different types of functions now, but they all function, they all work in the same way. To use the same word there, they all work in the same way. And so what I mean is this. This first one is linear. It's our classic y equals mx plus b. I just added an element. And think about go back to those y equals mx plus b. Here's our y-intercept. At the end, here is our slope. It tells us how steep the thing is, right? Now I just added, those still remain. I just added a little element here, which we don't normally see. And that tells us, that shifts it to the left and to the right. So even though it doesn't look like y equals mx plus b, it is. I just added an extra element, and it works the same for all of these. And so what I mean is, this right here, this is basically our slope. It tells us how steep the thing is going to be. It makes whatever it is steeper. Or the other way to think about it is, think about if we grab the top and grab the bottom and we stretched it. It's a stretch. Or if we grab the top and bottom and we shrink it. Oh, gosh. Spelling is on point right now. Stretch. There we go. Or shrink. That's what that tells us. And it makes it steeper. That is another way to say it. If you want to use the word steep, I'm fine with that. But technically, you are stretching it. All right. This is like our y-intercept. It remains the same. It tells us how far up or down we're going to shift our graph. That number out at the end. And then in here is closest to the x. So think about it. It's going to tell us how far to the left or to the right the thing is going to go. And keep in mind, it does the opposite. This is that weird one. I'm going to put it in a different color just so you can see this is opposite. So what I mean is that if it's positive, it actually goes in the negative direction. If it's positive direction, but just for that. Now you can see each of these graphs has a different thing going on. This one would be linear. It's just the classic y equals mx plus b. I just added an element. This one is the blue one is the absolute value. That's the V graph. I'll show you that. And I would suggest having Desmos open for this. I'll show you why here in a second. That's our absolute value graph. And then squared is maybe something we haven't dealt with. You'll see what that looks like. It is called a quadratic. It is squared. You can see that with the exponent there. That is squared. Now, these rules you do not actually have to memorize. I mean, eventually I think you might have to in future classes, but for now you don't have to because you can use Desmos. And that's what I would suggest you use. Now, let's read the directions real quick. It says, describe how the graph of each equation below compares to the graph of f of x equals the absolute value of x, or f of x equals x squared. Now, what in the world does that mean? That means that these top ones are originals. Now, all you have to do is match up which ones go with which. So what I mean is, this says f of x equals the absolute value of x. That is the original. That's called the parent function. We've done this before. This is where we add elements and it changes what it looks like. What I mean is, if I put a plus 5 in here, it's gonna, cool. There we go, plus 5. It's gonna shift it. If I put a plus 3 here, it's gonna shift it, which that is the first problem. We'll go over that in a second. But this is the original. These are the transformations. This is adding elements to the original. And you can see these second ones don't have an absolute value, so they don't relate to the absolute value. This one is the original. This is the original. These ones that I'm putting dots by those are the ones that those are the transformations. That's how they're going to shift. So you just have to match up which is which. So what I mean is for the first two, you're going to use the absolute value of x as your parent function, your original function. So you're going to type this top one right here into Desmos, like I have it. All right, just like this. You can see it looks like a V. Cool. Now, what I would do is I would do it step by step. I'm going to copy this and I'm going to paste it right here. Now, the original, you can see I'm going to click it here. You can make it disappear and come back. It's the same. They're the same. But let's do it step by step. We added a 5 on the inside with the X. So let's do that. Let's put that right there. And look what happened. Our original is in red. And we moved it 5 to the left. So it does the opposite when it's on the inside. Okay. Now, I'm going to copy it again. Should be a different color. Of course, it turned red again. Let's go ahead and redo that. There we go. It's blue now. And we had a +3 at the end of it. And look what happened. It went up. So you can do it step by step. Check it out. Started at red. That's our original. We shifted it to the left 5. And then we went up 3. And that's the final one. So what you're going to do is you're just going to type in the answer, which is, it says describe how the graph compares. We shifted it. Nice. Shifted it to the left 5 and up 3. That's it. That's what you did. All right. Let's go ahead and go to Desmos. And that's, so you don't have to use these rules. Now they follow, by the way. Look, it was here. This is the left and right. And it was opposite. So it went left. And then this number on the outside told us if it went up or down. So it follows these rules, but you don't have to memorize the rules. All right. So let's take this one step at a time. It has a 2 out in front. So let's go ahead and copy and paste it. Control V. It puts a 2 out in front. What happened? It got steeper. So you can say it got steeper. You can say it stretched. Think about if we took that red one, grabbed it on top and bottom, and pulled it apart, it would stretch and look like the green one. I'm going to refer to it as a stretch. You can say it got steeper. Next one, we're going to put a 4 on the inside. So copy, paste. I'm going to put a 4 on the inside. I believe it's a -4 on the inside. Yep. And it shifted it to the right 4. Can even zoom in a little bit so you can see there's the 4. And then finally, hold on. Copy, paste. And I think we have a +5. Oh, -6. Wrong. Looking at the wrong one. -6. Let me bring this back together. And then there's that one. So we shifted the purple one down. Now, as you get more and more steps, it's going to look really confusing. So maybe just go like that. What? Just go like this. Get rid of everything. And just go, okay, we made it steeper. Let's get rid of the red one. Then we shifted it over to the right. And then we went down 6. So to describe it, you just say, you can say it got steeper. I'm going to say stretched. I'm going to include the number stretched by 2. Shifted to the right 4 and down 6. That's it. You're just telling me step by step what is happening. All right, let's get rid of these. Now, the next 2, like I said, they do not go along with the absolute value. They do not have an absolute value. And you can see they don't have those lines for the absolute value, the bars. They have a square. So they go along with the x squared. So you're going to change it to, I deleted it, f of x. Remember, f of x is just the name of the function squared. And you can see it looks a little bit different. It's curved. It doesn't have that sharp corner, but it's going to act the same way. We have 3 things we need to add. We have a 3 on the outside. Put that 3. You can see it stretched again. It got thinner. Copy and paste again. We have a -2 on the inside. That should shift it. And you can see, I'm going to get rid of the red one to avoid confusion. It shifted to the right 2. And then finally, we have a +5 to put on the end. You can see it went up. So what did we do? We stretched by 3. So from the original, we stretched by 3. We shifted right 2 and up 5. That's all you got to do. Now, finally, again, it's x squared, so we'll keep it like this. Now, that 5 is on the inside, which changes it a little bit. So here's what I mean. Let's go ahead and get started. Let's go ahead and put copy, paste. I'm actually going to start with the 2 and the 3 first, just to say we know what's going to happen here. We know it's going to shift left 2. That +2 and the -3 will move it down 3. We know what's happening there. So we took our original, we moved it over 2 and then down. Okay. Now, there is a little bit of a difference here. If I put that 5, now the 5 is on the inside of the parentheses. I believe if I put the 5 on the outside, it'll look a little different, so it's stretched. Whereas if I put the 5 on the inside, it's still stretched, but it's stretched differently, right? So it has a minor difference, just as a heads up, but it's still going to be a stretch, whether it's on the inside of the parentheses or not. So you can say, I think the difference is this one technically shrinks it, and the other one stretches it. Either way, if you just want to say got steeper, stretched, they shrink, I'm going to stick with stretch just to keep things simple for you guys. Stretched by 5, shifted left 2 and down 3. So just make sure you can follow those rules if you want to stop. If you want to take a picture of this and use it, that's fine. If you want, I would suggest using Desmos though. All right.